Okay, guys, welcome. And ladies, everybody, welcome. I am super excited, as you could tell, because I love vibe coding, for today's webinar. And I really appreciate you all coming in. This is one of the pillars that we're committed to pushing over the next year is more hands-on webinars, things that get you out of the hype and into the tactical, here's what we're doing with it. So today we are going to be talking about vibe coding smart buildings, which is two of my favorite things. So physical gadgets and smart buildings and vibe coding and a mix of it in between. I'm all about crossing that digital physical divide. So just a real quick who I am putting this on. So I am a podcast host and researcher / futurist of Facing Disruption. We've been going at it for the past year. We are really trying to explore where emerging technology is reshaping industries and individuals, moving past the hype into tactical, tangible advice and outputs for literally facing disruption. And I run an applied innovation studio called MXP Studio, where we push human plus AI augmentation. It's all about augmenting and empowering individuals to do more with AI, not replace them. And why vibe coding real quick? This is why I care about it so much. So before, we were in a situation where it took a long time to build, right? It required dedicated software teams, a lot of expertise. You had 6 to 12 month project timelines. And then IoT systems really amped that need up because now you're talking more with embedded hardware, embedded devices. Look, we're not replacing that at all. But where we are today and what we're going to show you today is that one engineer can be supercharged to deliver full systems. Caveat, I would not put that in production. We'll let Ed get into that. The tooling costs has dropped dramatically and we can prototype within weeks, not months. And that's really, the biggest thing for this. So I'm going to introduce real quick Ed, and I'm going to let him talk more. He leads Twin Site Consulting. He is an engineer and architect and also the first and third guest on Facing Disruption 2 years ago. So I'm bringing him back. I gave him a challenge to do a webinar around vibe coding for smart buildings. And he said, okay, I haven't done it. I'm going to learn it. And then we're going to go and we're going to do it. And here he is to present it. So I'm going to stop sharing my screen. And with that, turn it over to Ed, who will be our MC for most of the rest of the webinar.
All right, so I'm gonna now jump into a presentation and start off, kind of describe a little bit about the project. We're gonna have a live demo in the middle of this as well, so that's always a risk. We'll see how that goes. The subject is old meets new, and I put vibe coding in quotes here for a very specific reason, because it's really more than just vibe coding, and I'll get into that in a bit. So about me, I'm a mechanical engineer. I've got electrical coordinate and control systems. I'm not a professional developer. I've got professional experience. It spans a lot of areas: automotive emissions controls, application engineering, product management, multi-domain simulation, 3D graphics, and game engine real-time 3D applications. I worked in the automotive industry at Autodesk for a number of years and at Unity for 6 years, which is where a lot of my game engine experience came from. So why should you care? There may be somebody in this webinar or who watches it who lives in a pre-World War II building with steam heat. Chances are slim, but if that's true, then this could save you money and improve your comfort. For everybody else, it's really understanding what role AI should play in the design, development, deployment, and support of systems, even complex systems. Because as AJ said, the rules have changed, the barriers have changed, but it doesn't mean that you just want to launch into this, head first without thinking. So we're going to kind of walk through some of my experience. Some disclaimers. First of all, the contents of this presentation are purely my own and don't represent the perspective of any companies I'm affiliated with other than Twinsight. Notably, Virtualware or Transform XD, this is separate from that. This system has not been fully tested and validated for functionality safety yet. It's provided on a purely as-is basis, no representations or warranties. It's not completely finished. The core functionality is there, but I'll talk a bit about what more needs to be done. And also, just it's important, I am not certified by ASHRAE or any other professional organization related to HVAC control system. So you have to understand that grain of salt. So why this project and why now? So I live in a 97-year-old building, which is similar to the one on the left. Originally coal-fired and now uses a gas-fired central boiler with lots of compromises. So this is actually a very personal project for me, in addition to being an interesting webinar, hopefully interesting webinar topic. And my question was, could I combine engineering know-how with modern technology to find a better way? So this idea took root. And the way I launched this was, first of all, I wanted to make the system simulation-driven, specification-driven, and I chose to use Google Gemini Pro and Google Anti-Gravity for development. I could have used Claude or ChatGPT or another tool, but I thought, let's keep it all in one ecosystem and see how that works. And as you are going to notice, also use Nano Banana Pro quite a bit for some of the images within the presentation. So the core problem is this system is on-off. There is one temperature sensor in one room in a building with 12 apartments, in my personal case. And that one temperature sensor essentially runs the entire building. Everything is manual. And as you can see, you've got a radiator, steam comes in, it vents out, it's mechanical. There's really no way to control the heat output other than controlling the vent, but it's a mechanical valve, you're pretty limited. So the building has been suffering from 97 years of compromise. The one-room thermostat controls the entire building. At best, the building can be balanced for only one set of conditions. You could put a variable mechanical vent valve, a standalone quote-unquote smart TRV, but you're not controlling the boiler with that. You could completely close off a radiator or, not uncommon, open a window, which is incredibly wasteful. So as you can imagine, this is a compromise both for comfort and for energy efficiency and cost. So the case for change is really threefold. One, improve the efficiency of the system, save money, have a lower carbon footprint. Two, comfort, so that you can adjust the temperature in any room to what you want it to be, as opposed to you get what you get. And then finally, diagnostics, being able to understand if there are faults in the system and, alert an administrator to those faults. So the overall coding chain here was using models. And so it's, not just purely vibe coding. It's starting with ideas and specifications and core model concepts within the project, and then using Gemini Pro as the LLM as the AI foundation, and Anti-Gravity as the agent connected to an IDE. So here's this question of, is it vibe coding or spec-driven design? Spec-driven AI coding, and this is purely my definition, reasonable people can obviously disagree on this. It's a high-level specification-driven process where a domain expert, or semi-expert in my case, describes physical behaviors and system logic to an AI assistant, which then implements the underlying code architecture. And what this looked like in reality for me is I started with a foundation specification. I did not start with a prompt to an anti-gravity agent. The first thing I did was research into the options, and I used Gemini Pro to help with the research as well, what the architectural options are. Should I use Redis, or should I use MongoDB, or should I use SQLite, given the amount of data I would be storing, the performance demands? How should we handle messaging? What are the options? So I made some human choices in that through the research aided by AI. I created a foundation specification which described the system in pretty good detail, not infinite detail, and there were a lot of things that I learned as I went along. But then I developed the architecture, and that then started feeding additional artifacts. So we had the foundation specification to start, but we also had additional artifacts that were implemented along the line. Then the process essentially became prompting, identify, something that I wanted to do, let Gemini go off and create the code. Then I would go test it. And then we had the thinking phase. And as you can see, it's mostly LLM on the top and human, me, on the bottom. Revising this, coming up with new ideas, and then going through the circle. And while I was doing this, it was also feeding the creation of additional artifacts, which are essentially both documentation and additional specifications. And this documentation is everything from user guides to implementation guides and things of this nature. And then the specifications also then provided a reference to the system as part of the context that was used for coding. And then of course you stop the clock when you get to the point where you have functionality that is what you want. So here's an example. The specification on the left, you implement proportional logic within the hysteresis band, blah, 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 blah. And then this is a portion of the code that was produced from that. And, so as you can see, I was fairly specific in what I wanted to do. And I had things like, I want to quantize the valve flow so it isn't constantly hunting. It only moves when it needs to move by at least 5%. Things like that, because you don't want to run the batteries down in these smart valves. So just, it's an example of what a prompt would look like. And this was above and beyond what was, this particular prompt was above and beyond what was in the original spec. It was an enhancement to the original spec. So what does the tech stack look like? Well, on the back end, it's Docker and Ubuntu server. Got a Nook that this runs on, and I have it running on a Nook, although I'm going to be demoing off a Docker container running on my Mac here today. But it's been tested. It works great. So it's very transportable because everything's Dockerized. It's all a Docker compose to spin everything up. I can just take that, throw it on Nook, and it runs just the same. On the back end, I've got Python for all of the core logic. Mosquito is an open source tool for, it's an MQTT broker, which is a message queue manager. SQLite for the database, and then a bunch of Python libraries that I'm not going to go into great detail on. And on the front end is Home Assistant, which is an open source tool that's widely used for these types of applications. There was no reason to reinvent the wheel on that, so I just integrated everything with Home Assistant. JavaScript for all the web front-end stuff, and then Bootstrap 5 is a CSS manager. There are some other small things in there, but I'm not going to go into infinite detail here. So that is overall the tech stack, and that's replicated both on the Mac within Docker and on the Nook.
So Ed, real quick,
Yes.
if you can go back to the specs and the diagram, I think 2 slides back.
Of course.
So I would love to talk a little bit, like, how did this used to work before? I'm going to say before AI, but that was literally like before LLMs were the capability that they are now. That was like 3 years ago. This was 3 to 5 years ago. What would the process look like for getting to the point where you're developing these specs so you could even build out the architecture?
I would say it, in some ways, if you're doing agile development, it's not so different. Obviously, in this case, it's a little different because I am my own customer. So the need to go out and get customer feedback and incorporate that feedback into the development loop was not an issue. So that's I would say the benefit of doing a one-off project of this nature. But in general, I would say it's not so different, because even if you're doing agile, you're starting with a product concept in mind. You have some minimum viable product definition. You're cycling until you get to the level of functionality you want, and you discover new things as you go along that you may not have originally anticipated, and you're capturing those in additional artifacts. So in a lot of ways, the core idea is not so different. Obviously, you don't have the LLM human split. And the most obvious thing is it takes so much longer. And uh, it's not just the amount of time that it takes, it's the number of people who are involved, and it's the economics that are driven by that. So I would say the biggest difference is not one of style, but of scale and time.
Mm-hmm. Yeah, and I think that it's really interesting because, something that we're not seeing here is the speed at which you're doing these iterative loops.
Yeah.
Right.
Yeah.
And that, I think, is the biggest benefit of all of these tools.
There's another thing too, which it doesn't come through in this chart, but it was a very real experience, which was I did this while I was doing all of my other projects. I've got an active consulting business. I'm working with customers on a day-to-day basis. And, I'm spending time on that. So what would happen is that I would go do a loop and it would go do something. Then I'd let it run for a while, let the simulation run, observe its behavior and so forth. And I would be off doing something else. And then I would come back to it and I'd think about it and let it soak in. So it was a very intermittent development process, but that offered the benefit of being able to take the time to reflect on the performance. But even with that, which made it, frankly, very low stress for me to develop, even with that, it was unbelievably fast. All right, let me jump down here now again to where we started. So the initial architecture was essentially we put in all the core building blocks. So had mosquito brokering MQTT traffic. We had this MQTT message bus. Have what we're calling Twin Manager, which I'll show you later on, which is essentially the master that builds and deploys everything. Had the simulation to emulate a physical system, and had Home Assistant for UI and control. And it was the dumbest system possible because all Home Assistant did was had a set point on one room. Is it too hot? Is it too cold? Turn the boiler on, turn the boiler off. Frankly, not so different from how the current system works. Obviously not with an MQTT message bus. And it was just these three processes: the Twin Manager, the Simulation Twin, and Home Assistant. And then down here, we have the configuration files to drive everything. This is probably a good place to point out the way this works is this can be expanded to pretty much any size building and can be implemented and modified over time. So what the Twin Manager does is it creates YAML files and JSON files that are dynamic and create everything. So the entire front end you see in Home Assistant is driven by a YAML file, which is published by the Twin Manager, which defines all the rooms, all the names, everything else. All the MQTT topics are generated dynamically based on the configuration of the building, and all of the simulations, everything is driven off these same configurations. So you essentially start from scratch, you hit the button in Twin Manager, and it deploys everything all in one fell swoop, which worked out really neatly. And it also facilitated adding new capabilities. So then what we did was added what I'm calling the simulation tuner, which lets me go in and adjust parameters. How fast is a room losing heat? How much heat is the radiator putting in? We'll get into some of those later. Also had the predictive twin, which there's technology called Kalman filters, which is a great way of tracking, being able to learn parameters that are interrelated, that have covariance among themselves, and to kind of pull the data out of a mess and to be able to understand the behavior of a system. And what that allows me to do is now learn how the building actually responds. This room cools down very fast. This room gets a lot of heat when the sun hits it in the morning, if it's sunny, these sorts of things. This one gets heat in the afternoon. And so now you can actually learn the performance characteristics of a building and get some pretty interesting information out of that. And of course, the idea is the predictive twin just follows whatever the simulation twin is doing with the adjusted parameters. Had a control layer, which is kind of the core of the system. And that does all of the control for the boiler, for the valves, and it is also responsible for fault detection. We still have Home Assistant for the UI, and I've got one thing on here that isn't done yet, but essentially it's the hardware interface, because right now everything's running in simulation, but the next step is to hook this up to physical hardware. So now I've got a Zigbee collection of devices, and have all those devices, all of the rooms, have a new process or a new application that assigns those together. Now all of a sudden you can run this in the real world, which is the plan.
Yeah, Mark was just asking about if you're going to be replacing mechanical valves with a digital valve control.
Yes, and I'll show you here when we get into the demo, which is now. First of all, what this looks like. So now what you can see is the status of the boiler, and this essentially the boiler relay is on or off. The boiler itself can be off, on but not yet producing steam, or producing steam, because there's a lag. And then here I have this hypothetical building with 1 floor, 2 apartments, 3 rooms in 1 apartment, 4 in the other. It's good enough for test purposes. And essentially the way this is designed, you can the core idea is you control based on the manual rooms, because they're sort of just, they have no control capabilities themselves. And so you can see here, it's averaging out these 2 rooms. One's a little cold, one's a little warm. It hits the middle point. And then it adjusts all of the automatic rooms to fit. So you can see the automatic rooms are really close. And you'll even see here when it's warming up, once it gets to a certain point, it'll start cooling more slowly because it starts shutting down that valve. You can also have it so that it runs completely on automatic valves. You can have an existing building and say, I'm going to add a room. You can add a room. You can take a room out. You can temporarily disable a room. So there's a huge amount of flexibility in what you do. If I go over here to the Twin Manager, you can see here, I've got monitors for system health. Are all of these applications running? I don't have the predictive twin showing here. And if they're, for whatever reason, are down, I can restart them. Then within the building, I've got the settings. Latitude and longitude is important because I pull weather data based on latitude and longitude. Time zone matters because we have this thing called quiet time. You don't want the boiler hissing and creating steam in the middle of the night, kind of noisy. So you can set quiet time parameters, which of course depends on time zone. We have, in addition to the data retained by Home Assistant, we retain data every 30 seconds for 3 years. Then you can pull that data and do post-analysis on it. Say you want to develop some new algorithms or something. We have some boiler parameters. We have various control parameters, hysteresis, minimum number of manual rooms to control, a max overheat limit that, is kind of a safety valve for the, so you don't overheat a room. Then I have default parameters for the room. How fast does it lose heat? What effect does wind have on how fast it loses heat? How fast does the radiator add heat? What is the sun load at different times of day? And we have a place where we can export data. You can choose a date range and download a CSV. And there are no active faults, but if there were faults, it would tell you which rooms, what the fault is, and you can clear the faults from here. And then you can see down here, got all of these rooms that are individualized. You'll notice down here that you can have valves. You can either have them automated or manual. And then if it's manual, you can say what the flow rate is for that valve. In the simulation tuner, it populates this based on the same configuration file. Purely for testing purposes, you can go in and adjust these factors. And then finally, the Kalman filter has configured and learned values. And this is what learns the actual performance of the system over time. So, like I said, next step is to add a hardware interface layer. But I've frankly beaten this system up quite a bit, testing it. And at this point, the control layer and the fault detection logic and the fault clearing logic is solid as a rock. I mean, I've thrown different things at it. It handles everything exactly the way I want it to. Kalman filter, I'm still working on kind of the convergence and stability trade-offs. There's, that's I will say it's very tricky to design a Kalman filter for a system that operates in multiple modes. Leave it at that. But I've managed to make it work. All right. So test-driven development. So this is the circle part of the chart that I showed earlier. So why TDD is non-negotiable? That even with good specifications, there's no guarantee that AI-generated code will follow the spec. For anybody who remembers 2001: A Space Odyssey and how, sometimes the machine doesn't do what you want it to do. So you have to make sure that you've got a control on that, and having a good spec and having a good test plan is mandatory to be able to get what you want out of the. Sequential prompting is a journey, and if you don't have a map, you can easily become disoriented. The other good thing about test-driven development is it forces you to think through the use cases, the edge cases, and the failure modes. What happens if you open a window in the room and it cools down real fast? And then, can you detect that? Can you clear a fault? These sorts of things. It's essential to catch regression errors in code and back to the how, not always knowing what the system, frankly, the system gets confused. The large language model gets a bit confused sometimes. And tests also become a form of system documentation.
So real quick, just to take a step back for those of you who might not be familiar with TDD and other approaches to development, can we just go over what is TDD? What are some of the other options? Why this one?
Yeah. So, TDD, at the end of the day, it's about having a test suite that you validate the system against. And you need to have a list of the requirements. In this case, do this. In this case, do this. Test these extremes. What happens if the parameters on rooms are set to unusual values? Does the system respond as you expect? You need to follow through and make sure that that you test. You think through as many of the use cases and as many of the potential faults and problems as you can. You run the system through all of this. It's also things like, I delete a room, I add a room. Are all of the MT message topics dynamically updated properly so that now the system is seeing the right rules, doing the right things? Does it track all of those sorts of changes? All of those tests are essential to make sure that the system is doing what you want. And yeah, you can go in and read the code yourself, which I've done. But at the end of the day, it's really no different from developing with a team of software developers. You ultimately have a set of requirements in mind, and you have to meet those requirements or you miss the goal.
That's something that I have started realizing myself, is that, what we're talking about with vibe coding and doing this AI assisted coding, which is really what it is. It's very similar to TDD. If the requirements you're putting in are garbage, the code is going to reflect that. Yeah. Or the other thing that we hear a lot about is, the code that's being produced doesn't handle edge cases. I would speculate that any requirement that you give an engineer that doesn't specify use cases or edge cases will also not handle the edge cases.
That's true. Now it's a little bit easier when you're working with a team of people, because people are going to come back to you and say, "Hey, wait a second." And I would say the one downside of AI assisted coding is, the symptofancy, the fact that AI tools tend to want to please you. They're no intern that doesn't want to cross you at all. And frankly, one of the things that I've done is I've explicitly forced the tool by giving it instructions to say, no, give me your, do a harsh assessment of things, and you can get better responses when you do them, frankly.
Yeah, Mark was asking about the prompting strategy a little bit. With decompensating and garbage results coming out of that. And he's asking about the limits before starting fresh. And my interpretation of the question is around context windows and how long do you keep up a conversation before it turns to garbage? And you say, yeah, we're going to start over with a new conversation. And I would add to that is, did you face that and what was your strategy?
I will say the good thing is by taking key learnings and key requirements and putting those in the spec documents and then telling the system you have to pay attention to these spec documents, that helped provide continuity throughout, even as the context might drift. And so I did not really run into context problems. I also will say, I think Gemini is, comparatively speaking, pretty good about having a large context window, which helped. So had I been using a different LLM, would I have gotten the same results? It's hard to say. I can't say. But I really didn't run into a problem. But I also think having a firm specification foundation was a major contributor to not having problems with context windows. I'll talk a little bit later on. I have some lessons learned about things that didn't go as well as I would have hoped. Not a huge barrier. I was able to work around them. But I'll get into things that not exactly context, but later on in the presentation on those. All right. Let's see here now. So here are some examples of test failures. So the Kalman filter logic learned some wildly inaccurate values for heat loss rates. So I had to then get into this, and this was honestly the hardest part of the entire system, was nailing down the Kalman filter logic so that it could essentially know when to learn which values, to oversimplify things a bit. Fault detection logic failed to exclude the room being evaluated from the average of all rooms, creating a bias in the fault logic. So if you had a room that was way too cold, it counted that into the average. Well, maybe you don't want to do that. You want to compare that room not to all the other rooms. And after a change of the MQTT message topic schema that was driven by a refactoring at one point midstream, some subscribers were still listening for old message topics. So these are the sorts of things that popped up when I was doing testing. Now I provide some reflections on the experience. So here's the prompt within anti-gravity in the agent. And this is some general thoughts. So the first is that AI is the ultimate garbage in, garbage out machine. You need to think deeply about what you want to build, because if you just kind of launch into it without planning sufficiently, it's going to build something, but what it builds may not be really what you want. And if you get too far off track, it's hard to find your way back to that path. When you're in a groove, keep going. That's the nice thing. You can really get into a flow state with this tool. When you hit a wall, step away and do something else while you quietly soak on it. And the nice thing about that is you can take your time to really deeply think about the problem and then come back. And then when you come back, you're no longer in the, picking up grains of sand with a pair of tweezers. You're working on this with power tools, and you're able to get the fixes implemented quite fast. And then finally, and the most important thing is work at a higher level of abstraction and think strategically about how to accomplish the goals. Let the agent take care of the gritty details. You just, because, anybody who's coded, you get in and you can kind of buried in the code at sometimes. And yes, you need to go look at the code, but you're no longer focused on the low-level details. You're really thinking at a higher level of abstraction. And that's the mindset you have to have. Some other experiences. I was pleasantly surprised at, and I know the word understanding here, I put quotes on it, but how well Gemini grokked the concept of physical systems. So once I got it pointed toward the domain and had it do some research into single pipe steam heating systems, I was honestly kind of floored by how little I had to explain to the system in terms of functionality. The front end work was really good. It's rock solid. I barely looked at the JavaScript code. It just didn't cause me any problems. There wasn't any need to go through it in detail. For the back end, I was impressed. Gemini was more Pythonic than I am. For anybody who's coded in Python, there's 10 different ways of accomplishing what you want to do. And in many cases, you can do it all in one line. And if you have the right naming conventions and the right Pythonic coding style, it can be incredibly readable and compact. Gemini did a great job on that. I was really impressed. Code comments were also solid. It didn't fill the code with comments, but where it didn't comment, the code was pretty much self-documenting, through variable names and the like. And then I would say refactoring was mostly a good experience, but there were some exceptions. So one of the things I noticed is that within one Python module, piece of cake, would handle everything just great. Where I ran into problems is when I got to a higher level systems issue where I had MQTT message topics that were used in multiple modules. And back to the context question you asked before, I don't know if I'd purely call this a context issue, but the fact that this process was publishing something on MQTT, all other processes had to listen to that topic, and these were all dynamically configurable topics that were specific to the original configuration. The refactoring sometimes messed that up. And so I frequently found myself going in, the classic experience, going, hey, this isn't working, da-da-da-da-da. Gemini goes and does some stuff, and it's, oh, gee. I discovered that this process was listening to the old definition of the message topics, not the do definition. Should have caught that the first time. And one of the best responses was when it came back to me and said, my bad. It was a particularly pointed response. I will say, when I pointed out the problems, what I noticed is the agent would then work harder to fix the problems. It might have been lazy the first time, but once it ran into a problem, it was better at kind of blowing past whatever internal limits it was imposing. And then earlier on, I had problems with the anti-gravity agent stalling out, forcing me to restart. That has since been fixed. I haven't had a problem with it for 2 weeks. I frequently noticed Gemini writing malformed edits. It would catch itself and fix them. No big deal, but it was a glitch. I was impressed with how Gemini handled functional decomposition in Python. I looked through the code line by line. There was really only one issue where it had duplicate code and an init function and then something else. And I had to say, you should really consolidate those. And it did it one shot, no mistakes. It was perfect. So that pretty good experience overall, I would say. Here's an example of the kind of responses I got from Gemini. So this is the part of the process of updating what's the Kalman filter. It's called an unscented Kalman filter. And I was pretty impressed with how it approached this. And it kind of said, okay, here's the strategy I used to accomplish this. And it worked pretty well at the end of the day. And I was surprised at how well Gemini was able to address a fairly novel idea of having this modal-based Kalman filter learning, which is, not the simplest topic. All right. So now getting to some of the final polish.
Quick question. I'm
Yes.
looking at let's go back to the response that you have.
Yeah.
And so it's interesting. Did you tell it to take the persona of somebody experienced in manufacturing and smart devices and the stuff that you're doing? Or did it just pick up through the way that you communicated with it, the way that you were putting your specs together and what you were asking, did it take that persona on itself?
Mostly the second. So in the specification documents, I put some things in, you need to understand these, you need to research this. So I gave it some topics to educate itself on, if you will. But that's really all I did. And then as I ran into problems, like for example, with the Kalman filter, I noticed that, it frankly had problems with the Kalman filter. That was by far the most complicated thing to develop. And when things didn't work, and I challenged it with, this isn't working right, we need to achieve this goal effectively. It on its own did a pretty good job going and doing deep research into how the filter pi algorithms within Python actually work and why certain approaches would work and others didn't, and it would adapt through this. So when challenged, when things weren't working, it was pretty good at going and doing additional research on its own. I was impressed by that.
Yeah, that's one thing I've definitely noticed myself doing is trading. Ooh, what's a good way to put it? Offloading my mental responsibilities, the thought that I need to do, trading that for the speed.
Yes.
So basically, I'm now offloading a lot of the deep thought, not all of it, but I'll go back and forth and say, okay, I have this rough feature spec. I have this idea of how we have to implement it. And now I focus more on this is the outcome I need. What are the best ways to approach it? And you give me your ideas first.
Yes. So people who know me know that I'm the master of bad analogy. So I'm going to give you a truly horrible one. It's like riding a horse. So if you've ever ridden a horse, you can steer the horse to where you want it to go. You pull on the rein one direction or another, give it a little nudge with your, with your feet or so forth to speed it up. So you can indicate to the horse what you want the horse to do. But when it comes to avoiding rocks or sticks or, the horse is going to do a lot autonomously. But at the end of the day, you have to be in charge. And it's the same thing with working with Gemini. You have to be in charge. You have to use a firm hand to guide it because it doesn't know where to go itself. But if you use that firm hand, it can do a lot for you. I don't want to say automatically, but without as much guidance, I should say.
Did you run into any situations where you had an idea of how to take things and it came back to challenge you on it? Because I know you mentioned that you didn't want it to be the yes partner. So
yes.
Yeah,
So and this was, I would say more early on in the process when I was developing the core architecture, the idea of what am I using to handle messaging with MQTT? What am I using for the database and those sorts of architectural questions where it came up with some suggestions for things. And, and I asked them, I said, you go figure this out and tell me what you would recommend. And they came back with what it recommended. And, in some of the cases, I'm like, yeah, that looks great. In other cases, I'm like, no, not good.
Mm-hmm.
And there was a little bit of back and forth in that process. And then once we started getting into the actual prompting, not as much, but one of the more interesting things was an experience where I said, okay, I would like you to give me a retrospective on this project. Tell me what you, really weird using you and I in this conversation, but hey, that's what it is. What did you, Gemini, do well? What could you have done better? What did I, Ed, do well? What could I have done better? And I forced it. I said, be blunt, be harsh if you need to. And it was actually very insightful and did include some critiques back to me. Yeah, these are the things you could have done better. So
interesting.
I found that very helpful.
I would love to hear from others if they want to share their experience with using AI to accelerate their development, and then also how they treat their AI. Because I think that a lot of times when I talk to engineers about how they're using vibe coding. The ones that push back and say, oh, vibe coding is really bad, don't seem to treat the AI as a partner like you're talking about. They treat it as a task jockey, like, go do this, come back. I don't like it.
Yeah. I will say my approach was to be firm but polite. And I know it's strange to talk about an AI having a personality, but it did seem to respond better to that type of firm but polite guidance. And because it ultimately kind of tends to mirror your behavior in a way. And not sure how that works within the billions of vectors that are encoded within the LLM, but I noticed you get a better response that way. It was very interesting. Yeah, I was never mad at it, if you will. So, so the final polish. So there is more to do. We've got to work through expanded fault injection to support testing. You know, the battery ran down on this device and this and that, and, you know, to really flesh out everything to make sure that it's working correctly. Have to complete and perform comprehensive validation testing. I've done a lot, but have not done a complete validation matrix yet. Need to implement multi-user authentication for control of apartment set points by individual residents. You know, my neighbor shouldn't be able to control my temperature, for example. And add mobile and remote access, add a bootstrap routine to restart if the NUC loses power, everything comes back up. Normally, because you want robustness in a system and security. If this is something which will be, you know, it'll be behind a decent firewall. We've got a pretty good network system here, but still, you need to make sure that this thing is as secure as you can be, down to two-factor authentication and everything else. So that's a big part of it. Next thing is hardware interface module for device abstraction, because, you know, what I want the ability to do is to actually have mixed devices. You know, we buy devices one year, next year some new devices come out, we put those in a different apartment, and, you know, what are the connection protocols, what are the transfer curves, how do you communicate with each of those? So the idea is essentially have a little mini device driver for each one, and as long as it's an available device, you just add it, you create the association of the room, and you're done. Extend the logic to support independent boiler control, kind of as entry level kind of. I'm not sure if that's needed or not. It's something I'm looking at. And start by installing the sensors and valves in one apartment to test it out. And then do the hardware integration and test the performance in a real world installation. Because absolutely the intent is to, you know, implement this in a real building and test it out. This is in Madison, Wisconsin. There aren't too many buildings like this in Madison, but there are so many buildings like this, for example, in New York City, quite a few in Chicago, these pre-World War II buildings. Somebody could benefit from this, but I want to make sure it works. Then finally, tying it all together. The opportunities are absolutely there. AI coding is eliminating barriers to building software solutions. Full stop. I think opportunities exist in every domain and industry. And you have to be realistic about domain skills, but unleash your imagination. The best way to learn is by doing. And the nice thing about AI-assisted coding tools is it's simple to start small. But there are still hurdles. You need to start with a business case in mind. And a business case doesn't need to be a 50-sheet spreadsheet, but you need to have a motive, a reason for being. You want to make sure you identify the benefits, quantify the risks, consider the holistic costs, because it's easy for me to spend this up. It took me about 4 weeks to get the system to the state of development it's in now. And again, that was not 4 weeks of working constantly, believe me. That was 4 weeks of very sparse, intermittent development. But then beyond that, you've got hardware costs, you've got ongoing support costs. So, there's more than just coding. And absolutely use rapid prototyping to confirm technical feasibility and validate ideas. And then start small and think big. Think about the larger solution and how it needs to scale. I think one thing that I'm really happy that I did on this project, and that I would advise anybody consider, use a decoupled architecture to improve scalability. The idea of having this message bus and being able to attach applications as subscribers and publishers of topics on that message bus made it so easy. It literally just took the predictive twin and bolted it into the existing application with no dependencies other than knowing how to read the data off the bus. You need to design robustness and reliability in from the beginning. There is a literal heartbeat signal that goes out every 5 seconds on the message bus that every process says, I'm alive, I'm alive, I'm alive. And that's how the twin manager knows if things aren't alive. The next step is to say, if an application isn't alive, in addition to logging it, actually boot it back up and, maybe send a text message to the admin. There's some stability issues. Move fast, but always keep the end goal in mind and validate. Final thing, you have to be ready, especially if you're doing this at an enterprise level, which I'm not in this project. But first of all, spec-driven AI development and digital twins both have crossed the chasm. There's no doubt about that. But you need to take the time to assess where you are and choose your first steps appropriately. And I see really 6 criteria to consider. Not all of them applied in this particular project, like not much of a governance issue on my apartment building project, but still. The data integrity, technical architecture, process quality, and that process quality is, how different teams within your organization work together, the strategic vision of what to achieve, the governance, and you have to have a decision framework. And I know, AJ, that you earlier had a webinar on the traffic light, the green, yellow, red.
Mm-hmm.
That's a very good framework to use to know when you should do something and when you shouldn't. And half the battle is knowing when you shouldn't. So we're toward the end here, and I know we're going to get to questions here, and I would encourage people to ask as many questions as you have because we have time for them. So first of all, AJ is available to MXP Studio. You see his email, his LinkedIn, and his website address here. Similarly for me with Twinsite Consulting, my email, my LinkedIn, and the URL for Twinsite's website would, depending on your needs, would encourage you to talk with either of us. And now it's time to move into questions. So I see in the chat.
Yeah, I love it. Mark has a great 3-part question.
Mm-hmm.
So we'll go through this one by one, and I love these questions because I also have some thoughts about it. Okay, so first question: do you use the same tools, models for prototype demo versus production?
In this case, yes. Now, would that necessarily be the case for anyone else? No. And let's face it, this was not the hardest system to design. When you're talking about heating systems, they operate in scales of seconds and minutes, not microseconds. So, to a certain extent, when you get down to, true high bandwidth, high frequency, real-time control systems, you may end up using some different tools. But in this case, yeah, absolutely. It was all one integrated system, and it's just going from prototypes straight into production. Although, admittedly, I still have to do the hardware integration. So
and that goes into
this. Go ahead. So given the dizzying pace of announcements with various AI tools and models, do you recommend picking one tool and committing for 6 months versus dabbling with a few? It's a good question. With this system, I made the intentional choice of sticking with one tool. with one exception. I was so frustrated with the Kalman filter at one point that I said, because Claude is available within anti-gravity with the Pro plan. I mean, with some rate limits, obviously, or some usage caps. And I used Sonnet 4.6, not Opus 4.6, but I threw the problem to Sonnet 4.6, and I gotta say, I know Claude's got a really good reputation. It completely screwed it up. And I had that too. And I think part of it was that it lacked some of the context for the problem. So I had to spend some time unwinding that one Sonnet prompt. Had I been developing the entire system in Claude Code with Sonnet or Opus, I'm sure I wouldn't have had an issue. So I did notice that one thing, which made me wonder about the merits of switching tools too many times in the same project.
Yeah, and I feel I echo the same thing. I feel like it depends on what your goal is as well. Do you want to learn the tool, or are you focused on delivering that specific project? Because what you said, I think that's right. The way that I use Claude Code, I use Claude in VS Code, and I've been very intentional with my project structure and the way I document and the way that I understand that Claude will use its Claude directory. I would imagine, like you said, moving to Gemini or another tool to try it out, I would have to relearn it as the user, and then the LLM will have to relearn the project. So it's an interesting experiment. Yeah, I definitely think it's what's your goal, right?
Yes. Yeah, exactly. And, but, frankly, my next project I'm probably going to do in Claude just for comparison's sake. And then is there a minimal amount of JavaScript, Python, and MQTT, which would make a big positive difference for people? I don't think, not necessarily. I mean, it's a case of just using the right ingredients for the recipe. And in this case, because it was, the good thing about Python is there is such a deep set of libraries. So Python has a native library for MQTT integration. It has a native library for SQLite integration. It has a native library for call-in filters. So there are so many things in there that the choice of Python, it was drop dead simple. JavaScript is just kind of the default for front-end work. And it's so ubiquitous and easy to use. I mean, I know there's TypeScript and other things, but JavaScript worked great. And I'm a big fan of MQTT because I've done other work around building automation, and MQTT for these types of applications, again, where it's not super high bandwidth, super low latency kind of communications. MQTT worked perfectly. For what I'm doing with relatively low demands, using the open source Eclipse Mosquito broker worked perfectly. Somebody who's in a true industrial environment where they're dealing with much larger quantities of data, we're going to want something like HiveMQ or, a more kind of performant application, but worked fine for my purposes. So I think it's really more a matter of just picking the right tools, the right ingredients for the recipe for your use case. So I wouldn't restrict it to just those particular languages and parts of the architecture. Let me see here.
So now that we've heard the whole story, given your experience, let's go back to that question that I had early on.
Yes.
Compared to what it took you to get to where you are now, and being able to say, okay, yeah, nonchalantly, I'm going to create edge devices, hardware that's going to control this. What would this have taken just a few years ago?
Yeah, I think the biggest problem is, I'm okay at Python. I'm okay at JavaScript. But quite frankly, if I had to on my own, learn all the details of handling QTT messaging within Python and the intricacies of, how because there are retained messages and temporary messages and all sorts of things, and learn all the ins and outs of this. I could have easily spent the last month doing nothing more than just learning how these tools work and doing nothing else, not having time for any client work, and so the biggest thing is that the lack of knowledge of the specific implementation, the real details, is not a barrier. And I saved myself so much time not having to learn the intricacies of something, which I may not do very frequently. Now, if I were doing this day in and day out, it would still be a time savings, because there's no way that I could write code as fast as Gemini or Claude can. But the biggest thing was just not having to learn the domain specific implementations for these particular technologies. Oh, go ahead.
Yeah, just before we get to Jay's question. So now that you've experienced this, how do you foresee this kind of bleeding into your existing consulting and the way that you are approaching problems versus how you have been traditionally? Do you see it making a big impact? Like, what is the changes that is going to happen to you now in your thinking?
I think the biggest impact is really, and so let's face it, I'm not going to go to a client and say, yeah, forget all that commercially available technology that's been validated and is used by, 500 or, 20,000 other customers. I'm going to vibe code something for it. I'm not going to do that. But in many cases, a lot of the problems that you run into in my line of work is integration among systems. It's glue. And I think the real benefit is being able to use a tool like Gemini, like Claude, like ChatGPT, or Grok. I haven't used Grok. But, being able to use those tools to more rapidly integrate the glue can frankly be a huge time savings with customers. And, customers like it when you can deliver something fast. So I really see this as filling in the gaps, the nooks and crannies, and being able to move faster and accelerate the pace of development for those types of applications.
Great. So let's get into Jay's question. The next steps to go from vibe coded prototype to market ready product.
Okay. So the next steps are going to be, well, first of all, filling out a complete system. So got to be able to integrate with real hardware. You have to have a performant way of integrating hardware. Install 30 radiator valves and 30 temperature sensors. And, well, how do I wire those in? Effectively. Logically, how do I hook them up? That should not be a tedious process. That should be as easy as possible. So it's thinking through the user experience of that. Because it's not just going to be me doing this work. If this is used by others, there are other people who are going to end up using this tool as well. Need to make it easy for them. So that's one obvious thing. The second thing is validation. So let's use the example of hardware interface. Somebody adds a Danfoss radiator, smart radiator valve, and it's on the Zigbee network. It's out there, it's broadcasting, but it's not assigned to anything. The system needs to be smart enough to say, hey, you have an unassigned valve. Or, similarly, you've got a room that's supposedly pulling temperature data, but there's no temperature sensor for that room. This sort of thing is the automated anomaly detection needs to be kind of built out and expanded. And then just more validation. Now, I will say my intent with this is not to market this product, or if you will. My intent is to, it is all up on GitHub, but it's currently the GitHub repo is private, and it will remain private until it's ready, because I don't want to send out something that's half-baked. But once it's to a point where I believe it's ready, with all of the appropriate disclaimers of use at your own risk, I'm going to publish this under an MIT license so anybody can take it and adopt it and use it. And then it's just more a matter of, and obviously this is something that I intend to test out here in one building first. And then, are there any issues or so forth? If somebody really did want to use this in production in another building and they wanted help with it, obviously that's something I would charge for. I'm not going to do that for free. But as far as the code itself, once it's published, they'll be able to take it and run with it. This is a proof of capability more than a commercial product. But I'm a big fan of open source, and I'll publish it with all the caveats that, yes, this is AI generated code.
Yeah. Yeah. What's amazing, I like the proof of capability, but it's also such a high fidelity proof of capability. Like, this is what is exciting me the most. And it's also a challenge too, because the expectations for what a prototype is rising.
Yeah.
Would you agree with that?
Yeah. Yeah. I mean, this is something that, honestly, had you asked me 5 years ago, hey, Ed, could you build something like this? The answer would have been, no, I don't have enough time. And now the answer is, even though I'm busy on a day-to-day basis, the answer is like, sure, yeah, I could do that. And that to me is just a huge game changer.
Yeah. I wonder, as people are getting into industry, as they're coming out of school, think about where we are now, and then your journey to becoming the expert. What recommendations do you have for them? Because I know, we've talked about this on the podcast, right? We're facing disruption.
Yeah.
People are worried. Am I going to have a job? Am I going to have a job? How do I react to it? What are your thoughts there?
I think the key is, this kind of gets to the whole question of what is the impact of AI on employment, which is, well, nobody knows for sure, but I think there are both positives and negatives for it. I think what it's going to do is it's going to change the nature of work. So I think the idea of just sitting down and coding and that's all you do is probably too narrow. You want to combine the ability to code with some other domain knowledge, or know how to work well with someone where you partner with someone who's a domain expert, and then you are the code expert, and then you end up using tools like these to deliver and develop a product. And you still have to know how to read code, because I've gone through not every line of JavaScript, but I've gone through every line of Python. I've looked at, MQTT message logs. I've done all this kind of stuff to understand what's going on under the hood. So this isn't just a blindfold hit one button kind of process. You still need to understand what's going on within the system, and you need to understand the technology. But I think what it means is you just need to move up toward being more of an architect, more of a domain expert, partnering with people who have the skills needed to help deliver a system. It just changes the level at which you have to operate. But it doesn't remove the opportunities. In fact, I think in some ways it creates new opportunities.
Yeah, I feel like what I'm hearing is we're going to see a resurgence, or not a resurgence, but a surge in hybrid roles is what I've been calling it. You have to be a coder and industry, and you just can't be that thing.
I agree. Don't pigeonhole yourself and define yourself too narrowly, because take on additional roles, learn and partner with other people who have skills you don't have, think more broadly, develop your skills more broadly. You've got to be adaptable in this world.
And I would imagine there's still the room for the expert specialist. When I think about my AWS days, the network engineer who is working on the infrastructure, handling 50 million users, 500 million users. Like, these are bigger than some nations. You still have to have a very specialized skill set. But I would say that they're also able to think broadly about the impact because it matters.
Yes, 100%. And Winfrey just put a comment in. I'll read this up. It's interesting to think about the future implications of using LLM models. I mean, right now it requires a certain skill level earned from years of experience to say this LLM response is useful or not. But how will that change when thinking 5 or 10 years ahead? Will LLMs become the new pocket calculators that everybody uses, possibly not knowing how to get to these results? There's no doubt about it. What we've seen today at proof sophisticated projects can be done in a fraction of the time now with the AI support. I wholeheartedly agree with this. And I will say it's important to understand the underpinnings of the system. It's important to have a concept of how LLMs work. It's important to have a concept of system architecture, because if you go into it blindly, it literally can be blind leading the blind as far as the LLM, and you can get off track pretty easily. So I think it's very important to stay grounded and understand the capabilities. At the same time, when I was in school doing microcontroller development, this was in the 80s, I'm going to date myself. But at one point, I remember I had a class where I was doing not even assembly language coding, did literal opcode programming of a Motorola 6800 processor. I never want to do that again as long as I live. I mean, that's an extreme level of detail. It's helpful to understand how the system works, but never in a million years would I develop a system at that level. So I think it's more a matter of getting a foundation, but once you've got that foundation, learning how to use the higher level tools. Engineering schools ban calculators and math classes for a reason. You still need to understand the fundamentals. Absolutely. I'm going to look into the law of leaky abstractions because I actually am not familiar with that one, shamefully enough, but I'm interested. But I completely agree. You still need to understand the fundamentals. And if you go into this and you don't understand enough of the fundamentals, you're going to get lost.
Yeah, absolutely. I mean, I like your example. I think about it as well as we are abstracting away from the lower level code, and it's getting to the point where JavaScript will be the lower level code. Yeah. We're just prompting. As you know, the 5-10 years, how many people go and optimize in assembly at this point? We don't. Right. So probably not even 5 years, 3 years at this speed, 1 year, we're just going to be prompting.
And here's a good expansion on that. So I think, for example, if you really super optimize something that you're writing in an assembly, you can get incredible performance out of a processor. And it's true that we tend to be a little wasteful with CPU, GPU, and RAM these days. But at the same time, I would argue that most of the issues that we run into with the inefficiency of systems aren't necessarily because, a C++ compiled project is less efficient than assembly code. I mean, yeah, sure, 20%, I don't know, something versus perfectly hand optimized code. But the issue really gets down to bigger things like, I'm sending a message every second when in reality I could get away with sending one every minute and it would be just fine. And as a result, I'm flooding the network with too much traffic and I'm getting, bandwidth issues. The most of the problems that show up, I think, in the real world are a result of poor design choices, not necessarily poor tool choices. Yes, there are poor tool choices, but that's not the fundamental problem. That actually reinforces, I believe, Catherine's point about you still need to understand the fundamentals. Because if you don't understand the fundamentals, you easily build something that's crazy in terms of its implementation, and you don't even know how bad it is. So you need to watch these things.
Yeah, things break at scale. That's what it is. So maybe that could be a interesting next step, because you've already built the simulators, turn them up instead of 5 seconds, it's milliseconds, and see what happens, and see how the system behaves. And then on top of that, you could feed that back to Gemini and say, hey, at scale, this is what we're facing at. How do we fix it?
Yeah. One of the things that I've been thinking about how to perform testing on this, I'm completely riffing at this point, so don't take this to the bank. But one of the provisions I've already built in is the ability to accelerate the simulator, so you can speed up how fast it heats up and cools down. So you compress the time required. And then one of the other things I'm looking at is just spinning up a bunch of parallel Docker containers so that you can, a little bit like, who was it in the Doctor Strange with the 10,000 possible scenarios, spin up all these different scenarios and essentially run parameterized test matrix in multiple Docker containers at once. Not sure which way I'm going to go with that, whether it's parallel or accelerated testing. There are advantages to both, but those are the types of things I'm looking at. And, effectively, once you get the right test suite, you make a change, you run it through the test suite, and you know whether it's good or not before you release an update.
Yeah. It's honestly, it blows my mind that everything you just said is now a evening project.
Yes. Yeah.
Take the weekend and say, I'm going to create a scaled testing scenario for this platform.
This is why a thing that it would have been a major engineering project for in teams, to implement something like this, or maybe not major, but
it would have been significant, right? We were building out edge control devices using Raspberry Pis, Node-RED. I love Node-RED. I mean, I still love Node-RED. But still, that took multiple engineers a couple weeks, and then we had a lot of testing and iterating. And, to turn that into a few prompts, I do a lot with N8N now. And I gotta be honest, I don't even use the editor myself. I have Claude write the JSON file, and I stick that into N8N. I feed the error back, and I'm just like, do this for me. I have to get something done.
Yeah. And, why not do it that way? And again, the key comes, and I think this comes back to, but if you're going to develop a test plan, you still need judgment to know what to test for. So you have to bring judgment to the process.
Yeah, absolutely. So that experience, I don't think is going away for a while. I do, my concern is how are juniors coming into the market going to get that experience? And they're only going to be able to do that by living in it. They have to see the problems. The great saying from back in my Accenture days, there's no compression algorithm for experience.
Right. Yeah. Honestly, my advice, and I worry about this too. I've got, grandkids who are 3 and 6 years old right now. What is the world going to be like when they're entering the workforce? And honestly, and I help out with students from time to time. Sometimes it's like, hey, somebody at this company, and I do what I can. And what I've noticed is just in the past 18 to 24 months, the challenges that many people, especially with computer science degrees, have had in finding really good roles, and it's worrisome. And I think one of the things that that people need to do is, from the very beginning, work at implementing real, meaningful projects, and do hobby stuff. Get hack things together. Be a part of a hackathon. Because regardless of what you're doing, the tools you're using are changing. But what hasn't changed is the need for these applications. So, my advice to anybody would just get your hands dirty.
I love that. And we'll open it up for any last questions. And then if we don't have any, I'll just close up and tell you a little bit about MXP Studio and how you can find this information afterwards. Going once, going twice.
I think to add to what Edward just said, I think like a lot of these problems you learn about through experience. So like if you're young entering the field, right, and you have AI vibe code something, there's probably going to be like something non-performant about that. And like as you scale, then you have to debug that performance problem. And so then you learn, and then you're forced to kind of take apart the card and figure out what does it actually do and what is actually going wrong here. And so I don't think that AI is going to mean people don't learn in the future.
Yeah, I agree. I think in a lot of ways it can help people learn faster if they're committed to learning. But
I agree with that. The people who are curious are going to be the ones that get ahead. And that's exactly why I push this idea of human plus AI, right? Though AI is set to supercharge the people with experience or are the most curious, because it's no longer about, I don't know how to do this. It's about what are the questions I need to ask to do this. And I love that. And, something Mark just mentioned that I do these vibe coding seminars a lot, and mostly for non-technical individuals so that they can understand the pivot we've gone from for that questioning and this idea that you can envision something and almost will it into reality, right? You don't have an excuse. And now I'm excited that Lovable is going to be providing support, education materials, and credits to the work that I'm doing to bring things like that. So our next webinar, we'll have to do a live coding session for edge devices with Lovable. Really excited. It helps to push the mission forward. And that's what I'm bringing with MXP Studio, AI strategy, upskilling, product development, everything that how do we move faster and more effectively with AI as a tool in our toolkit. And Ed, you're like a great example of go out, learn to vibe code and build the thing that you've wanted to build and show what's possible.
Yeah, I'm a guinea pig for get your hands dirty.
Yeah, I love it. Let's see. One more thing, AI, the booster for the curious. Yeah.
I like that. I
love it. I mean, this is one of the few emerging technologies that have come out that I really, I'm all in. Are we in a bubble? Yeah, but the bubble is different from the capabilities of AI, right? The bubble is something completely different. We are on the precipice of an entirely new world, and I'm excited to bring that to the market. I'm excited for you to bring that to the market. I'm excited for everybody else here. You've shown that you're curious. Let's build something amazing. Let's build a lot of things amazing.
All right. Thank you, AJ. And thanks for everybody who attended. And thanks for everybody who watches this in recorded form later on. You've got our contact information. So, don't hesitate to reach out. Really appreciate it.
We'll send all of this out. It'll go out on our YouTube channel. Our channel name is Facing Disruption, and we'll also put it up on LinkedIn. I'll shoot an email to all of you that registered on Calendly. So spread the word, try something this weekend, have fun.
Yeah. Awesome. Have a great weekend, everybody.
Thanks, everybody. Thanks, Ed. Bye. Thanks, JJ.
All right.
Well,
hey, everyone. Thank you.
Yep, we're all going. Okay.
It's just us now. All right.
It's just us, yeah.
I'm happy with how that went. I hope you're happy with how that went.
Yeah. I think that was great. We did.